Have you ever gazed at the night sky and wondered why all galaxies look like circles? It's a common question that probes the deepest corners of our universe. When we look up, our eyes are greeted by a spectacular celestial dance of stars and galaxies, most of which appear circular to us. But is that really their true shape? You see, space isn't as straightforward as it seems. The galaxies we observe are a cosmic potpourri, each unique in size, color, and most importantly, shape. Some are spiral, others elliptical or irregular. Yet from our vantage point here on Earth, their vastness and distance often distorts their true forms, creating the illusion of circularity. It's a fascinating conundrum, one that challenges our understanding of the universe and the way we perceive it. So why do galaxies appear circular to us? Let's delve into the science behind it. To understand why galaxies appear circular, we need to comprehend the nature of light and how we perceive it. Light, my dear friends, is an enigmatic entity. It behaves as both particle and wave, a concept known as wave-particle duality. It travels at an incredible speed, about 186,000 miles per second to be precise. This speed is so immense that it remains constant regardless of the observer's motion. The journey of light is equally fascinating. It emanates from a source, such as a star, and travels in a straight line until it encounters an obstacle. This can be anything from a speck of cosmic dust to a gargantuan black hole. When light interacts with these obstacles, it can be absorbed, reflected, or refracted. When it's absorbed, the light disappears, swallowed up by the object it has encountered. When it's reflected, it bounces off, much like a ball hitting a wall. And when it's refracted, it is bent, drawn off its original course. Now, let's consider our eyes, the windows to the universe. We perceive light through our eyes, which function like a camera. The cornea and lens focus incoming light onto the retina at the back of the eye. The retina is lined with photoreceptor cells, which convert light into electrical signals. These signals are then transmitted to the brain, where they're interpreted as images. So, how does this relate to galaxies appearing circular? Well, when we observe a galaxy, we're not seeing its actual shape, but rather the light it emits or reflects. This light has traveled vast interstellar distances, encountering numerous obstacles along the way, and has been refracted by our atmosphere before it reaches our eyes. This journey can distort the light, bending it in such a way that the galaxy appears more circular than it might actually be. In addition, our eyes and brain interpret the incoming signals in a way that simplifies complex shapes into familiar forms. Circles and spheres are among the simplest and most familiar shapes to our perception. Hence, the distorted light from the galaxies, when interpreted by our brain, tends to be perceived as circular. So, the way light travels and how our eyes perceive it play a crucial role in the circular appearance of galaxies. Gravity, the force that holds the universe together, also plays a significant part in the shape of galaxies. Picture this. You're holding a handful of marbles. You release them and they scatter in all directions, right? Now imagine those marbles are cosmic particles. And you're not just letting them go, but you're in the vacuum of space. With no external forces at play, what happens? The particles, or marbles, begin to pull towards each other thanks to a force we are all familiar with, gravity. But why does this result in a disc-like shape? Well, that's because of the way gravity works. It pulls everything together towards a common center. Over billions of years, this pulling force causes the matter to collapse into a disc. Quite fascinating, isn't it? This disc is predominantly flat and rotates around a central bulge formed by the densest concentration of matter. The rotation creates a centrifugal force that counteracts the inward pull of gravity, keeping the stars and other celestial bodies in the galaxy from spiraling into the center. Now, why does this make galaxies appear circular to us? That's because we're viewing them from a great distance. When we look at a galaxy edge-on, we see it as a thin linear streak of light, with a bulge in the middle. But when viewed from above or below, the galaxy appears circular because we're seeing the full face of the rotating disk. This is why galaxies like our own Milky Way and our neighbor Andromeda appear as spirals when viewed from a certain angle. They're not perfect circles, but their gravitational pull has formed a disc-like structure that appears circular when viewed from afar. So, to sum up, gravity is the cosmic artist that sculpts the galaxies. It pulls matter together, forms it into a disk, and sets it spinning. This causes the galaxies to appear as spirals or circles when viewed from a distance. Gravity, thus, is instrumental in giving galaxies their circular appearance. Another factor that contributes to the circular appearance of galaxies is their spin. Now let's delve into the heart of the matter. You see, galaxies aren't just static, stationary space entities, they're dynamic, constantly in motion, spinning around a central point, often a supermassive black hole. This motion, this spin, plays a crucial role in how galaxies take their shape. Imagine a spinning top. As it spins, it spreads out, becoming wider at the equator and flatter at the poles, much like our own planet Earth. The same principle applies to galaxies. As they spin, the stars within them distribute themselves in a circular pattern around the central point of rotation. This distribution creates the beautiful spirals we associate with galaxies like our own Milky Way. But why do galaxies spin, you might ask? That takes us back to their birth. When a galaxy forms, it's born from a collapsing cloud of gas and dust. As this cloud collapses, it begins to spin. This is due to the conservation of angular momentum, a fundamental principle of physics that dictates that the total amount of spin in a system remains constant unless acted on by an external force. The conservation of angular momentum ensures that as the size of the spinning cloud decreases during the collapse, its spin rate increases. This is the same reason an ice skater spins faster when they pull their arms in. As the cloud continues to collapse and spin faster, it naturally forms a disc-like or circular shape. And voila, we have a spinning galaxy. But it doesn't stop there. Over billions of years, the spin of a galaxy can influence its evolution, affecting the formation of new stars and the paths they take. This, in turn, can further enhance the galaxy's circular appearance. So the spin of a galaxy is another key factor that makes galaxies appear circular. The spin isn't just a footnote in the cosmic dance of galaxies, it's a leading player, a driving force shaping the universe as we see it. The spin, it seems, really does make the galaxy go round. Lastly, the vast distances involved also contribute to the circular appearance of galaxies. This is where the concept of perspective comes into play. Now imagine you're standing in front of a very long fence. When you look at it straight on, you can see it's a long, straight line. But if you were to look at it from one end, the fence would seem to curve and converge into a point in the distance. This is perspective in action. Now, let's apply this concept to galaxies. These cosmic entities are not just thousands or millions, but billions of light years away from us. Light years, mind you, is the distance light travels in 1 year. It's an astronomical unit of measure that's incredibly vast. So when we observe these galaxies from such a colossal distance, our perspective of their shape is distorted. Consider the spiral galaxy, for example. Its arms stretch out in a vast cosmic dance, yet from our distant vantage point it appears more compact and circular. The sheer distance involved compresses the galaxy's true form into a smaller, more rounded image. This is similar to how mountains in the distance look like tiny bumps on the horizon. However, it's important to note that not all galaxies appear perfectly circular. Their appearance can vary based on their orientation relative to us. A spiral galaxy seen edge-on may appear as a thin, elongated strip, while the same galaxy viewed face-on may appear circular. So the distance doesn't just make galaxies appear smaller, but it also affects our perception of their shape. It's like looking at a coin. From the side, it appears as a thin line, but head-on, it's a perfect circle. Therefore, the immense distances involved also play a part in the circular appearance of galaxies. It's a fascinating interplay of perspective, distance, and the inherent structures of these celestial bodies, reminding us that there's always more than meets the eye when it comes to the mysteries of the cosmos. So why do galaxies look like circles? It's not a simple answer. We've delved into the infinite expanse of the universe, unraveled the mysteries of light and the role it plays in our perception of galaxies. We've explored the omnipresent force of gravity, how it shapes galaxies into disks and clusters them into groups and superclusters. We've discussed the dizzying spin of galaxies, a dance choreographed by the laws of physics, and how this motion contributes to their circular appearance. Then we've looked at the illusion of distance, a cosmic mirage that makes galaxies appear smaller and thus more circular the farther they are. It's a fascinating journey, a cosmic ballet of light, gravity, spin and distance. While galaxies may not be perfect circles, our perception, influenced by various scientific factors, makes them appear so. The next time you look up at the night sky, remember the fascinating science behind those circular galaxies.